Welcome to the NDT Systems Raptor Corrosion Inspection System Setup video. Here we will discuss all of the equipment that's included in the CIS kit, as well as how to set up each individual part and get you ready for inspection. Included in the kit is a Raptor flaw detector, an auxiliary battery pack for the RCA scanner. This comes in 10 or 18-inch variations. We have a armadillo hand scanner, and we have a cable to connect the RCA to the Raptor flaw detector and the auxiliary battery pack. First, let's take a look at how to set up the Raptor for use with a dual element probe. To calibrate a dual element probe, you'll need the dual element transducer. This one goes in the RCA 10 or 18 and is at RCA 053. You'll need a cable to connect it to the Raptor flaw detector. On top of the Raptor there are two connectors, TR and R, transmit, receive, and receive. Go ahead and connect the red cable to the TR and the black cable to the R. We'll also need a step block with known values. This goes from 1.75 inches down to 0.062 inches. However, for our lower bound, we'll use the 0.1 inch value. We'll also need some couplant to couple the probe to the step block for accurate reading. Let's look at the menu structure of the Raptor flaw detector. On startup, push any key to go from the splash screen to the main measurement screen. Using the arrow keys or the scroll wheel, or the function keys along the sides, navigate to the setup option, select load, ultrasonic, and select the dual 5 MHz 1/2 inch probe profile. This will set up the gauge for most of the functions that we'll be using with the RCA 053 dual element probe. Next, couple the probe to a step block of known thickness. We're going to select 1.75 inches for the upper bound and 0.1 inches for the lower bound. We'll want to do this to make sure that our range is set up correctly. Coupling to the 0.1 inch block, I can see a strong echo, but coupling to the 1.75 inch part of the block, I don't see any echo. To fix this, we'll go to calibrate, we'll go to range, and we'll use the up and down arrow keys to adjust the range until we see an echo from the top part of the step block. Go back to the lowest bound on the step block to make sure that we're still within bounds. Next, navigate to 2-point cal. We're not going to bother with IP block at this point. The IP block is this bar here, and as we can see, it's past the initial pulse, but less than our lowest step block value. Navigate to low thickness. Couple the probe to the lowest thickness. Push enter. We're going to select 0.1 inches. Next, navigate to high thickness and couple to the high thickness on your step block. Push enter, enter again, and enter 1.75 inches. Again, these are the values for my step block. If your step block has different values, use those values. After you've done that, hit calibrate, and the gauge will give us a list of adjustments that it's made, our new 0 point, and our new velocity of sound. Push enter to accept. You can go through the step block to verify that the calibration is satisfactory. Once you've calibrated your probe, we can go ahead and set up the gauge to accept a scanner. Push the escape, go to Scan on the menu, select Scanner. For this first example, we'll be using the RCA 10 or 18 automated pipe scanner. Push Enter, and now you're ready to connect the scanner and start a scan. Now that we've calibrated the dual element probe, let's hook everything up together and get ready for a scan. First, we'll need to put the dual element probe in a probe holder like this. Then we affix the probe holder to the scanner arm. Make sure you screw it into the detents on the arm so that it doesn't move unnecessarily. Then connect the probe cables. Then connect the couplant feed tube to the back of the probe holder. Then take the RCCB cable and take the Amphenol round connector and connect it to the back of the RCA unit. There is a unique keyway, so it can only go in one orientation. Connect the feed tube from the RCCB cable to the unit and connect the red BNCs together. As well as the black BNCs. Now that you have those connected, go ahead and take the D connector and connect it to the top of the Raptor. Next, connect the red BNC to the TR on top of the Raptor and the black BNC to the R. Connect the feed tube from the other end of the RCA cable into your feed system. This will supply couplant to the probe. Finally, take your power connector and plug it into the top of the external battery pack where it says scanner, and then go ahead and push the power button to turn it on. A blue LED will appear on top of the external battery pack, and a variety of LEDs will appear at the back of the RCA. Now to set up this for a scan, we go from the main menu, Scan, we go to Scanner, make sure we have RCA 10 connected, go to New C-Scan, and set your scan area. I'll set it to 3 by 3 inches. 3 inches on the x-axis, 3 inches on the y-axis. I'll keep my increment values the same, and I'll raster along the y-axis. And when I'm ready, I'll hit Accept. I'll move the transducer all the way back and over a little bit. Once I've done that, I'll offset the transducer a little bit from the edge of the travel and hit Enter. This will be my home position. Now, if you have a couplant feed system, go ahead and activate it, or you can go ahead and put a little couplant in between the probe and the test material like so. Now you're ready to scan. Push Start Scan and wait for the results. Here's an image of a finished scan. We've got a color bar along the bottom to indicate relative thickness, as well as a ruler scale from 0.5 to about 1 inch. The red areas will be areas of the thinnest material and denote corrosion. The blue areas will be the thickest material and will be recognized as our known nominal value or good areas on our sample material. We can save the scan by going to Option 8, Save Scan, giving it a name, in this case ASNT Pipe 3, and we can either save it internally or to an external SD card. I'm going to save it to an external SD card. Go to New Location, F1, push F2 to use the external SD card, and push Save Here to copy it to the external SD card. Hit Menu when you're finished, and push Enter to save. We can also take a look at the image and manipulate it in a variety of ways by going to the Image tab. We can change the scale, the color bar properties, we can zoom in, we can take a look at a B scan generated from the C scan data. We can take a look at a histogram of commonly measured values. We can populate the data in a 3D view. And we can measure any particular spot to find a thickness at a designated spot. Let's move on to the Armadillo hand scanner. The setup for the Armadillo hand scanner is similar to the setup for the RCA. There's no external battery pack, however, so it is a bit easier. Take the D-sub connector and connect it to the Raptor as before. And connect the BNC cables to the T and R on top of the Raptor. There's no red or black, only black, so the orientation doesn't matter. Next, go to Scanner on your Raptor. Select AEHS-03 for the Armadillo hand scanner. Go to New C-Scan or B-Scan. We'll do a B-Scan in this case. And select the range of measurement. We'll change this to 5 inches. Couple the probe to the test piece and place it at your starting point. Push Enter when you're ready. Go to Start Scan and feel free to move the armadillo across the sample to find areas of corrosion. You can see here that there's a little bit of black at the top of the scan. That'll indicate an area of pitting. Unlike the RCA, this is not automated, so you have to manually finish the scan by pushing Enter. We can manipulate the image as before. We can make a 3D view, histogram, and we can zoom in on specific areas, and we can also save the scan to an internal or external SD card. All these scans are usable with the RapWin inspection software that comes with each Raptor unit. If you'd like to know more about the Raptor corrosion inspection system or any other NDT products, please give us a call or visit our website. Thank you.